Hello. The purpose of this video is to learn about solving systems of equations by graphing. Now, I created this using a program called Explain Everything, and I do have some shortcomings with it. You will notice that this graph here is not all that accurate. I had to draw the lines manually by hand here. My X and Y axis, although they're nicely marked here, do not have the arrowheads on the end. My dot here, although when I do put it on some places, it may not show up very well. So please be patient with me if there are issues with the way the dots and stuff work. Thank you. Okay, now a system of equations is any set of two or more equations. In this case, and in this video, we're focusing in on only two, no more than two equations. Now, sometimes, occasionally, they will write the system with a fancy bracket containing the two equations like that. Not necessary, but you may see it there. The equations do not necessarily have to be in this y equals mx plus b. That's a slope-intercept form. But for the purposes of this video, we are having them in this slope-intercept form to make it a little bit easier here. So that being said, to solve the system by graphing, we need to graph this equation first. Doesn't matter which one I graph first, but I'm going to graph this equation first. I'm going to start off with its y-intercept of -1. So I take one of these points, and I put it at the y-intercept of -1. Oh, there we go. All right. Now, the next point, to find the next point, I need to work with the slope. Now, remember, slope is rise over run. And when you have a whole number like 2, you need to put it over 1. So the rise in this case is 2, and the run is going to be 1. So we take this point and we rise up. From our beginning point of the y-intercept, we rise up 1, 2, and go to the right 1, and that's our next point. That's the rise of 2 and the run of 1, a positive slope. Now this also lets us know that we can tell that this is going to be a positive slope, because if we think of that money versus time, this is a good thing happening to our money, so it is a positive slope, which is good. All right, to find another point, we would then go from this point, we would count up 1, 2, and go to the right 1 from that point, and there, now we have another point. Still in that same line. If I wanted to go in the other direction, instead of going up 2, I'd have to go down 2 and to the left 1, because going down would be negative. That would make that a -2. I went down. Going to the left, which is what we did here, going to that left is another negative, so we have a -1 in that direction, and a -2 over a -1 is still a +2 slope. Still continues in that same line. All right, so that's enough points for me to draw the line, so I'm going to go over here and I'm going to widen my drawing tool here a bit. Let's see, go there, and we're going to draw a line through those points, and we put an arrowheads on the end, because the line does continue in both directions. Now, you should be doing this with a ruler. Hard for me to do that on my iPad here, but you should do this with a ruler. So please make sure that you make nice straight lines using a ruler. All right, now we go on to the second equation. Here's the y-intercept of 3. So I grab one of these points and I'm going to put it at 1, 2, 3 on the y-axis. To find the next point, I work with the slope, which is -2, which means that the next point is going to go down 2 to the right 1, and hey, that's a common spot. Oops. That's a common spot with the last line. Pretty interesting, isn't it? Then we take another one, we go down 2 to the right 1 from there, And I can make another point by going down 2 and to the right from there. There's our line. We draw that now by grabbing this. We go draw a line through those points. Arrowheads on the end. And there is our two graphs. Now notice that the two graphs cross right at that common point there. Now remember, when you draw these lines, the reason why you're drawing these lines is because every single point on this line is a solution to this equation. Every point on this line is a solution to this equation. So this point right here is very special in that it is a solution to both this equation and this equation. It's the solution that works for both. And that coordinate, that xy value of 1, 1, is your answer for the solution to this system of equations. This one coordinate will make both equations true. To test that, I would plug it in. Now I gotta reduce my pencil point here again. So if I plug it in, I plug in 1, 1. That first equation would become 1 equals 2 times 1 minus 1. Oops. 2 times 1 minus 1, which would indeed give you a 1, so that does double check there. Now let's try the second one. 1 for y, negative 2 times 1 for x, plus 3. I'm plugging in this x and this y to this equation. You'll see that this works out to be negative 2 plus 3, which does give you a 1, so that double checks as well. So that means that this truly is the solution to my system of equations. Okay, this is another system of equations. This time there's some fractions in it, but it's still the same thing. We're going to start off by graphing this equation, working with this y-intercept of negative 1, and this slope of rise of 1 and a run of 3. So we grab one of our points, move that to negative 1 for the y-intercept. Then we grab another point, we go up 1 and we rise 1, 2, rise 1 and run 1, 2, 3 to get to that point. And then we grab another point. From there we go up 1 and over 1, 2, 3. There's another point there. And that's about all we're going to fit on this graph. So I'm going to take this opportunity to draw a line through those. Let's see, we go like this, put the arrowheads on it. Again, you guys should be doing that with a ruler, making it nice and straight. All right, and now we go to graph the second equation. To graph the second equation, we work with the y-intercept. We work with the y-intercept of 4 and the slope of negative 1/2, which is a rise of negative 1 and a run of 2. So I grab this point, put it at the 1, 2, 3, 4 on the y-axis. Then I grab the next point to point down, not find the next point, I go down 1 to the right 2. Find the next point, I would go down 1 to the right 2. Find the next point, I would go down 1 to the right. Hey, there we go. Overlapping points. Now from there, we do need to finish the graphing part. So we do need to draw the line through these points, put the arrowheads on it. Again, you should be doing this with a ruler. The coordinate is this coordinate right here, although my graphing is not very good with that. That would be the point there, which is the coordinate there is indeed a 1, 2, 3, 4, 5, 6, it's a 6 in the x and a 1 for the y. Double checking, if I plug in 1 for y in the first equation, 1/3 times 6 minus 1, 1/3 times 6 is 2. 2 minus 1 does indeed equal 1, so that double checks. Plugging into the second equation, 1 for y, and we have a negative 1/2 times 6 plus 4. Negative 1/2 times 6 is negative 3 plus 4, which does equal 1. So that double checks as well. So again, the solution, the actual final solution to the system of equations is this coordinate. That's the one xy value, one set of xy values that will make both equations, both of these equations, true. And that's what makes this a solution to that system. Okay, one more example for this video. All right, we're going to start off with the y-intercept of negative 3. So I grab this, plot it at negative 3. The slope, the slope is 1/2. So I grab this, and from this point I go up 1 and over 2. Another point will be up 1 over 2. To put some of the other direction, I would go down 1 to the left 2. That's still a positive 2 slope. It still keeps that same. Okay, so now to draw that, I draw a line through those points, putting arrowheads on the end, and there's my graph. All right, now I need to graph the second equation. Now here it might be a little confusing because there's no plus b, but remember when there's nothing on the end here, it's just like saying plus 0. The y-intercept in this case is going to be the origin. So we're going to take one of these and plop it right down in the origin. And the slope is 2, so we go up 2 over 1 to find another point. From this area to go down, I would go down and to the left 2, down 2 to the left 1. Sorry, I'd be going down 2 to the left 1. And then for another point there, I would go down 2 and to the left 1, and I end up at that same point right here. So there is our solution for this one. But before I finish writing that solution down, I am going to need to graph that line. So I graph the line through here, put the arrowheads on there. Now I write the solution out. The solution is a coordinate pair, and the x-coordinate is negative 2. The y-coordinate is negative 4. And this is your solution to this system of equations. And you could double check it, and you should, by plugging it back into both of these equations. First one, we have negative 4 is equal to 1/2 times negative 2 minus 3. This part's going to give you the negative 1/2 times, 1/2 times negative 2 gives you negative 1. Subtract 3 from that, and you do get negative 4. So that part double checks. And if you do negative 4 is equal to 2 times negative 2, so that double checks as well. So this is definitely your solution to this system of equations. I hope you've learned something from this video. I hope it's been helpful. I know it hasn't been the most entertaining of videos here, but hopefully it has helped. If so, please feel free to subscribe to my channel. My channel is mfunk4. My first name is Matthew, my last name is Funk, and I use the number 4 because the other ones were already taken. I do not monotonize this channel because I do not want extra commercials on it. I hope you do appreciate that. Again, please feel free to subscribe, comment. I do try and reply to the comments when I get time. And hopefully it's been helpful. Thank you.